Talk to you about a library that I've written 2 years ago about Unicode, which is called Boost Unicode, and to implement Unicode facilities, I designed a system to deal with conversion and segmentation of arbitrary ranges. Just a little joke here. I'm probably used to this if you dealt a bit with UTF-8. Sometimes text appears a bit like this. So, for instance, when you read UTF-8 as letting 1. So this the code is available on the sandbox. So the documentation is also available on the internet, matthias.gurn.com/unicode. So what I really need for this library to be ready for review is feedback, because I haven't got much feedback when I talked about it on the mailing list. This is really the main reason why I think it hasn't been submitted for review yet. So first, let's talk a bit about what Unicode is. A lot of people already think Unicode is UTF-8, UTF-16, but it's more than that. It's basically a character set that takes all the characters from all languages, and there's about 1 million entries, so you can't just put all characters into a 16-bit integer. You have to use a 32-bit integer, or those encodings we'll see later. And what the character set contains is called code points. The entry in the set. Each code point has all the information associated to it. What kind of character is the letter? It's a number. It does have certain properties. It can also be decomposed. We'll see later about decompositions. Canonical decomposition, but it's also compatible to decomposition. So, for example, there's a character which is 1 on 4, and you can decompose it into 1/4. It's one of the decompositions available. And each character can be set to uppercase, lowercase, title case, and there's also case folding, which is different than the other ones, because it doesn't mean anything for language purposes. For example, the lowercase and uppercase version of the sigma character in Greek is different depending on the position of the character in the word. But case folding doesn't really care about that. It's just something you should use if you want to do case-less comparison. So, as I said, the decompositions, and you can compose characters by combining them. The mechanism to combine characters is you have one base character followed by the number of combining characters, and it is defined a single combining character sequence. So there's lots of algorithm within Unicode to deal with these sequences. And then you have another distinction, which is a grapheme. Grapheme is really the real character instruction. This is the character as the user will see it. And so Unicode provides algorithm to delimit these graphemes, thus word sentences. About words, it's not always possible in certain languages to distinguish different words. So Unicode does the best effort, and it advises implementation to use dictionaries if you want to do real word delimitation, because in languages like Japanese or Thai, there is no clear distinction between words, no white space. And then finally, there are algorithms for comparison and sorting. For such different type of sorting, sorting for notebooks, for phone books, and different. The central one is the most popular things about Unicode, the UTF encodings. So as 21-bit, it's not really practical. You can encode it into 3 different forms. There are more forms available, but these ones are the most popular. So UTF-X means that you're going to encode on X, on units of X bits each. And so for UTF-8, you're going to have 1 to 4 code units. It's called a code unit. The unit to which you encode. Well, 1 code point becomes 1 to 4 code units, or 1 to 2 code units in UTF-16. and the UTF-32 is, of course, not variable width. So the variable width is something that makes dealing with Unicode very different from the character sets, because you cannot just use random access as you would normally do. So about combining character sequences. So as I said, you can have one baseline character followed by any number of combining characters. There's no limit on that number, but Unicode allows you to set a limit of 32 if you want to do something that requires fixed buffer. This is something that I do in Unicode. And of course, you can have many different representations for the same character, because you can combine the code points as a combining character. You're combining code points in different orders. So that's why there is a canonical ordering, and you've got normalization forms, which are fully decomposed or fully decomposed and recomposed. That's NFC. Typo. So the second example. So I actually had to use an image here for this character because LaTeX wouldn't let me put it. So there's different ways to represent it. The fully pre-composed way, one which is half pre-composed, because we still have E with the dot below, but we add a combining circumflex point, and then the fully decomposed version, which is E followed by combining dot below, followed by combining circumflex. And you also have the same, this and this is the same, except the combining characters are not in the same order. This is equivalent, but this is not canonically ordered.
So is there a defined canonical ordering? What is that?
Yes, it's defined. It's defined according to some property of the code point. Combining class is called. You sort. You actually do a bubble sort on the combining character sequence using the combining class. So we've seen the different ways to see a character. The code unit, which is basic encoding, basic signature encoding in UTF. The code points, which is the entry in the Unicode character set. The combining character sequence, and the grapheme cluster, which is the abstract character abstraction. So this is different from combining character sequences. So what's a character is really up to you. You can choose to, depends what level of granularity you need. Sometimes you just want to work at the code unit level, the code point level. Sometimes you want to work at the grapheme level. So my library allows you to do all that. So what do we need for Unicode as a library? First we need to set up the table that contains all the properties for each code point. So this can be pretty large because you've got 1 million code points, and each has maybe 20 properties. And this data is different depending on different locales. Because some properties can be considered to be different depending on which language you're going to be dealing with. So that's why I think we need to have dynamically linked libraries so that we can change the library by one more tailored to a particular use. And since we have libraries, it needs to be at least backward compatible. This is really just give me a code point, I give you give me a code point in the property you want, and give you the value for the property. This is very low level. This is used for lookup database purposes. It's not really the features we want for the users. So there is an implementation of the library as part of the Boost Unicode library. It's based on some work done by someone before. I don't remember his name, but unfortunately, but something I inherited from the Boost vote. It uses Spirit Classic parsers to basically gets all the information is available on the Unicode website, and you can parse it and do whatever you want with it. So there's a parser that generates the tables to be used for the library. To remove redundancy, I use a two-level memory structure. It's also forward compatible because I check on the either side. I check that the property returned by the binary library matches values that we know And if it's not Bayesian, we know we can fall back to unknown. And for composition, this is a bit complicated because I need to take a decomposed string and find ways to compose it. So I need to expose prefix and suffix trees. Suffix is just for if you want to iterate right to left. So I need to come up with a better IBI, I think, to expose it because it's not very good at the moment, but it works. So what we really need for Unicode, the thing with Unicode, I think, is that we can basically two categories of things that we're going to do with text. We're going to want to convert text, transform it, and transcode it between character sets, do normalization, transform case, and segmentation. So we want to be able to iterate through the code points of a range, through the characters, different types of characters, the words, and all that. We want to be able to, from a random position in a string, find where is the closest word, the closest boundary of a word, the closest boundary of a code point, and to be able to sync for substrings in a bigger string for matching, for parsing. And yeah, and normalization is of course not stable by concatenation because if your string on the right starts with a combining character, you might have to renormalize the bit in the middle. So, if we want to do all that, maybe it's the solution having yet another string type. That's a popular solution that comes up often on the Boost mailing list. I don't think this is a good solution. I think it should be more centered on the algorithms themselves rather than the data. So I want the algorithm to be able to work with a string type, wherever it is stored. I have no problem with memory allocation, so do as little memory allocation as possible when we need to be able to control it. I want to be able to combine different types of transformation. We want it to be fast, of course. There's no use in something that's slow. There's some use, but you can't reuse it. And I also want to avoid duplication. I want to be able to define something once and be able to reuse it for many things. And it should be easy to use. So mainly qualities or something like this. I hope I've come up with design that satisfies them. So this is range based. I'll explain later what the range is. I will need to write primitive once, and I can reuse it, combine it with different mechanisms. I could do eager or lazy evaluation, something more that. And then we talk a bit about how it can be written with SIMD, but I'm also doing an SIMD talk tomorrow, so I'll give more detail about that tomorrow if you're interested in that. So a range is basically any type from which you can extract Begin and the Bayesian iterator. And like iterators, can be refined, you've got a hierarchy of concepts. Containers are ranges, a pair is a range. There's also an iterator range class, which is just a glorified pair. It's quite practical, more practical than iterators, because you only have one object. You don't have to say begin, end every time you want to use something. This gives tensor syntax. You can use it with Boost for H or the C++ export loop. And the Boost range is a library that provides most of the tools you need to deal with ranges. That's also some pretty cool range adapters which were added quite recently. So this looks, adapters look a bit like this. As input, we've got a vector. So I got it wrong here, it's not R, it's B. And so you have this vector is a range, and we're going to build a new range, which is this range filtered by predicate P. P is a function, P and F are functions of type P and F. So we're going to build a range which is filtered by P and transformed by F. So that means that the range here is, this is B, but as we iterate it, we're going to remove all the elements that do not satisfy P, and then we're going to apply F on the result. So this gives us a mechanism for lazy evaluation of transformation on ranges. But unfortunately, transform is only element-wise. Compared to transformation, just apply transformation on an element. Of course, yeah, you can see that the type of the range is quite complicated, so probably you don't want to write it. So like it's the same thing that when you use Proto or DSLs, you have a long expression that's quite complicated. So I recommend that you don't write it out. Use auto if you can, or don't make the variable, keep it temporarily. So yeah, as I said, we're going to define a mechanism for doing transformation for Unicode, for example, UTF-8 to UTF-32 conversion. That can be done as well lazily in this way. So to do this, I'm introducing a few concepts. This is a converter concept. This is the main concept in the library. This basically models a step of a conversion. So because what we're going to do is we're going to try to apply a conversion step by step with an iterator adapter. So what it does is that it works for bidirectional ranges. So in here is in and out are iterators. This is a bidirectional input, bidirectional iterator. This is an output iterator. And so left to right and right to left will consume some of the input string, input range, which is defined by begin and end, and will write some input on to out and to return. And so it's when it does that, for example, left to right, it will consume some of the range. And the advance begins, once it's not constantly going to be modified. And then you can check that it doesn't reach the end, for example, the end. And the other way around, when you do right to left, you will modify end and write something to out. So the input, there is a few types that are used for generating the right iterator adapters. The input type is only used for concept checking, so if you disable concept checking, you don't need it. It's not archetype, it's basically a type that satisfies all the requirements for your functions. So this is the type, value type of the in iterator. The output type, what kind of output you need to put in out. Max output, how many elements you're going to write to the output, and maximum. This is optional. If you do not specify that, it will be heap allocated. And the alignments, which is just says all the output buffer should be aligned if you need to do, for example, assign this stuff. So it does look. Basically, I've defined a converter which is called U8 decoder. So as you might think, U8 decoder does UTF-8 to UTF-32 conversion. So this is, I use the convert function, but I also have commutative functions that directly decode UTF-8, U8, because there is a U8 decode, something like that. So, for example, you have your output as UTF-8, as a string, for example, but you can have a string literal, you could have an array, you could have a vector or anything you want. And we're going to want to write it to this buffer, which is a passing string of char32, because the library defines a few types. char32 is one of them, which is like char32t from C++X, but it is also compatible with C++3. So what we do, first we convert the input data, the converter, and then the output iterator. This output iterator does a pushback on this range. So what this do is going to eagerly convert this line, will copy into UTF-32 data, the converted form of UTF-8 data. Then you can iterate it, for example, with for each. So you get each code point. You can do the same thing lazily, which is quite shorter, doesn't require you to allocate any additional memory, but it can be a bit slower, and you don't have as much control about when things get evaluated. So the syntax for this is use the convert version for adapters, the lazy version, gives a string as input, this will be UTF-8 data in the string, and the decoder. And this will return you a string range, which will, as you iterate it, generate you the char32 code point that you can use, and you can then print like this. If you don't want to do your evaluation without pushback, you can also do it in two passes. First, you count how many characters you need to have. So here I'm using the counting iterator. This is an iterator from Boost iterator, which will simply count how many times it has been incremented. So first we run it with the counting iterator. So then itbase gives us the size t corresponds to many times it has been incremented. So we can allocate the data here, and then we just have to directly here converts the data, and we don't need to do pushback. We directly write it into the vector. There's something quite similar, which is a segmentor concept. It's basically like a converter, but it doesn't have output, and it also has a type. So this is used for segmentation. So when you want to iterate over words, over graphemes, over code points, but not convert them. What does it look like? You're going to use a UX segmenter, which is it segments a string or a UTF-8 string with code points. So you get 2 of the code points, but you keep them in UTF-8 representation. You don't convert them. This is quite faster than converting them. And so you get a sub-range. So you get a range of ranges when you do that. And each sub-range is the code point. The type of the sub-range is iterator range, so iterator type of the input. So again, if you had the good for each auto, you could avoid having to put this. So this is a segment function, does the segmentation. And so we do first for each loop, and then we iterate each car within the sub-range. So we print the code points, but as a list of the code units to contain it. And there's a boundary checker concept, which is here to, that's the last concept I will introduce. This is just a concept that tells you whether a position opposed within the range begin and lies on the particular boundary. So, for example, if you have a graphing boundary, you have a graphing boundary position model boundary checker, which will tell you whether a position is on the graphing boundary or if it is in the middle of a grapheme. This is quite useful if you want to you have a random position and you want to find the next one. So of course, all those concepts are quite related. I can define, I can combine them, I can to build new things. There's a multi-boundary, first builds a boundary checker, that's test for first boundary, applies a converter, test for another boundary. I can make a segment from a converter simply by discarding the output. Not the input, sorry. I can build a segment from boundary checker simply by advancing until the boundary is found, and then I can apply the segmenter before a converter. Don't exactly remember which. I've used all of these to combine and create new ones. I will demonstrate afterwards. The multi-converter does first apply the converter, then tries to apply a second converter on the output it has got. So the steps must well combine, because the output of the one step is used for the input of the second step. The other one works the other way around, but it only works if the first converter has a max output of 1. I also have a way to define the converter concept of define, that I define using a code conversion facet, which is a standard facility. I use this when I want to generate converters from the local subsystem. Okay, so you have 3 ways of using converters. You can also define a code conversion facet. I really don't recommend doing that, because code conversion facets are terrible. They're very slow, not easy to use. They've got a lot of guts. You can do with an iterator adapter or range adapter. You would apply the conversion step by step. It's quite practical, because you don't have to really think about where I'm going to store the data or where I'm going to allocate the memory. Or you can evaluate it in Titlib, which is the fastest thing you can do, but is a bit more involved. First, I want to say something about the segmentation. Maybe I'll go back here. Recently, a new library has been accepted to Boost. It's called Boost Locale. The way it does segmentation is that instead of returning a subrange, it's going to return you a new STD string. So every time you iterate through a particular substring, you're going to have to copy the data. So everything I did, I was careful to not do any copy, any memory allocation that was not needed. through that. So everything is defined in terms of these bytecode primitives. I've got a cast converter that just casts the output to a different type. UTF-8 decoder encoder, same thing for UTF-16, and the boundary checker for UTF-8. You've got the local UTF transcoder, which is built from the code conversion facets. It's UTF because it returns WCART, which is not necessarily, we don't know what it is. It is either UTF-16 or UTF-32, depending on the implementation. Because the combining binary that tells you whether you want a combining sequence binary, the grapheme binary tells you whether you want a grapheme cluster binary, and the decomposer and composer. So decomposition, decomposition simply calls the decomposition property and needs to recursively decompose everything, then canonically solve them. And the composer does something different. It's only if you want to, it really only works if you have already a fully decomposed string. If you recompose it using trees of strings, trees that contain all the fully decomposed forms, and then map them to the composed forms. So from this I can define a lot of things. Because UTF decoder, which will code the matching UA decoder or U16 decoder, depending on the size of the input range. The encoder does the same thing, but that cannot deduce it by itself. You need to provide its input argument. The transcoder does decodes some UTF-X and outputs some UTF-Y. So you just have to define when you want to transcode from and to. We've got Latin 1 encoder, which is basically just a cast, because Latin 1 is Latin was fully compatible with the Unicode character set, except when you are in UTF-32. But when you have UTF-8, you have to re-encode it because the characters are this 8-bit of UTF-8 is different. Local decoder just composes the transcoder I saw before. And the normalizer calls decomposition, then composition. So I got UTF variants of the various segmentation and boundaries. So you have two ways to segment UTF-8. You can use the converter and discard, simply discard the output, or you can use a boundary and simply advance it, which is much faster. Then the combination with the combining boundary, the grapheme boundary, the segment versions are segmenters. And you got also the normalization that directly takes a UTF-8 string, normalizes it, and gives it back to UTF-8. When you want to search within a string, there are two ways to do it. You can either fully decode a string and perform the search algorithm on your decoded string. That works. This way you can reuse generic search algorithms, but this is usually not very fast because you spend a lot of time decoding and searching. What you can do is that works with most encodings, especially UTF-8, which have very nice properties. You can simply work on the code unit level, and the matches just you find. Those that do not lie on the right boundaries, you can just discount. So we'll see more about that with an example. The second solution is faster, because usually you don't have many position matches in the string you're going to look for. So this is an example. When I'm going to search for the string foo inside the input string foo, this is some combining character and foo. So normally I'm going to work at the grapheme level. So this is foo followed by a combining character. I don't remember which one it is. I think it's this combining circumflex. So this O is actually the O circumflex. So we don't want to match this, and we don't want this to be a match in our search. We just want to find the second one. So what you can do is use the find first algorithm from boosted string algo, which finds the first match for a particular search. So we will provide decoded. No, we don't even need decoded, just segmented version. We adapt it into a range of ranges, with the sub-ranges each being a grapheme. And since sub-ranges already have comparison operators, it will work. You will be able to compare and check if these are the same strings. So we need to adapt this. The type you get there will be very complicated because it will be a sub-range of this range. But this is it will match the second. It will correspond to the second one. The second way you can do this is you can adapt the finder. So in boosted string algo, you've got this concept of finder, which is all algorithms are actually defined with. So you could actually have there's a first finder, but because it could be extended to add a Knut-Morris-Prats finder, because this just has a naive finding and anti-finding. So we just need to adapt the finder with a boundary. So say we will build a new finder, but which will discard all matches that do not lie of this one. And if you do that, you can just do find past the finder, and you will get the iterator range directly on the original, the iterator type of the original input. It will be much faster to do it this way. So, what does UTF-8 decoding look like? This is the algorithm I would do this. I do not guarantee this is the best way to do this. I just did it 2 years ago, looking at the definition on Wikipedia, basically. So what we'll see is that we're going to consume 1, 2, 3, or 4 different elements of input. So in reality, with the converter, it's not a return, it's write to input, but I wrote it as a return so that it fits on the slides. So we're going to cast it to 32 bits, depending on. So the first byte tells us which case we are, whether it's 1 character, 2 characters, 3 or 4. And then we can build the code point simply by doing some bit shifting between the different bytes. So I'm really wondering whether this algorithm is vectorizable. The answer is not really, because as you can see, you've got a lot of big problems. It's variable width. You read 1 or 4, and for everything you're going to do vectorized, you need to have a fixed input, fixed output. There's other problems. You've got branches. You've got promotion, because SIMD reduces fixed width. So when you promote, you're going to have to split to several registers. So it's not really something that's very easy to vectorize. Nevertheless, since I also work on the SIMD library, I wanted to be able to vectorize it. So the 3 problems are promotion, branching, and data to consume that step variable width, and the data is interlinked. You don't have all the first characters, all the second characters. You have the first, second, this, and that. So we could define within the system a new decoder, which is going to be a U8 fast decoder, which will, instead the U8 decoder, the normal decoder, it reads 1 to 8, 1 to 4 bytes and write one code point. If we were to write a fast decoder, so it will have to put 4 code points, because we would do it in parallel. And less if we don't have data, we will need to have a fixed input. So we need to do part of the work in Scala to first have pad it, to pad it with zeros, so as to have a fixed size of input. And we'll also need to transpose it. So I won't get into too much detail about this, because this is a few concepts from the SIMD talk, so I don't think this is understandable without explaining everything. But this part, this is the final thing you can do. Basically, it's exactly the same code, except we've removed the branching, we've replaced it with the select, which is basically the same thing, but it will evaluate all branches. So when you decode UTF-8, usually you only in the first case when you only have bytes. So if you evaluate all cases, all branches, this is not going to be very fast. So it's really a trade-off. What we'll say, what we could do is detect which case we are in if all the, because we're going to decode four code points at the same time. We could decode this all four code points are in the same case, and in that case use an optimized algorithm, and branch with a real branch. And we could get at a maximum a 4 times speed up. But I haven't really benched this still, because I'm still working on this. I need to tell whether the best option to do. It needs a lot of fine-tuning depending on what kind of input you expect. And as we did here, a lot of people do this, I've seen in other implementations. Instead of doing a simple if, they put a likely specifier that you can use for instead of compilers. That allows you to say this branch is very likely, prefer it over other branches. So since stacks, you could assume that most stacks contains mostly ASCII, so you could decide that this is more likely, and you could use it to speed it up. Okay, and this is actually all I've got. How much time have I used? Not much, I suppose.
You got 45 minutes left.
Okay, so half of it. So has everyone understood? Do you have questions, maybe?
I have the impression I formed was that you attacked the whole Unicode problem.
Mm-hmm.
And that's really good, I mean, because one of the problems with other proposals I've seen is that there were always cases where somebody said, I want this or that or the other thing, which it was possible, but a library just concentrated on certain use cases, essentially. And so I think it sounds like you can compose the components you've got to deal with.
Yeah, that was the idea. Building the components separately, just actualize them once, and you can compose them to do whatever you want. It's really algorithm-centric, so the algorithms are there. There's nothing forcing you to use them, so you can use whatever you want. If you just want to work at the code unit level, you can just do that. You pick what you want, basically. It's the idea of the library.
So the use case, like, say I decide to set myself up as a Unicode consultant.
Yeah.
And I have no idea. I want to be able, what problems I'm going to run into. And if anyone comes to me, I want to be able to solve their problem. I want your library and I want it bad, because I can probably attack any problem. I'm worried where I'm not, the use cases I'm not seeing are somebody who wants to do one or two extremely simplistic things, often just simply involving conversion is probably about.
Yeah, so the most interesting thing you want to do is convert between UTF encodings, and that's it.
And maybe do some things like compares that are, with a little bit of control over them, case sensitive versus case insensitive, that sort of thing.
Yeah, I forgot to say that obviously you need to normalize the strings if you want to compare them correctly.
Yeah, they're, okay, but
if you want to
The-
work as a beyond
the
the good point of-
user who has that very limited problems doesn't want, the fact that the library can solve a whole other set of problems for that particular use case, if all you give them is the ability to compose a solution, that's not good for that user. They want a pre-composed solution essentially. And I'm not, I haven't gotten a sense yet whether you in fact provide that, or that's another level of higher level of abstraction that would have to be provided by an additional library. Do you understand where I'm coming from? The use case thing, the different simple use
So
cases.
using something like that is not easy enough to use.
You're getting, I mean, you're getting there. You're pretty damn close. Let's put it that way.
Yeah.
Okay, so suppose, I think you kind of like touched on this at one point, but like suppose I have a string of Japanese characters and I want
Yeah.
to break it into words. You talked about using a dictionary and
Yeah, at the moment the library doesn't support words. Don't support it, but like I could implement it using the properties defined by Unicode. But the basic Unicode character database doesn't do, it just does the best effort thing. For Japanese, you really need a dictionary, so it won't be able to give you as good results as ICU, for example, which uses dictionaries.
yeah, so like is there a play, like I don't know how do I hook in my like I bring my dictionary and how do I hook my algorithm?
Well, you have to define, the best way probably to define either a boundary checker or a segmenter, a new segmenter, and you can just use it to apply it to generate, to convert your range to range of ranges.
Okay.
Yes?
So just to press Beeman's point a little bit further, I think, the obvious, maybe naive, but the obvious interface for doing the eager evaluation conversion would be an implicit conversion between UTF-8 strings and UTF-32 strings.
Yeah.
And this is a long way from that easy.
Yeah,
You have to put together a lot of different
I
parts.
decided to take an input iterator instead of returning the range, so that people have control of all the memories allocated. But maybe I need both.
I think it's a beautiful thing to have. You know, it's like the question of, are you just providing the basic toolkit, or are you going to give people everything they need to operate conveniently, even if they don't care about efficiency all the time. And a lot of people doing string manipulation are not caring that much about efficiency when they're doing it, because the bottlenecks are elsewhere.
Okay, well, I think you probably need to put it together, but I don't know which way it should be put together, because every time you want to make a new string type, it just turns into a batch of discussions.
Yeah. No, I agree.
So that's why I decided to focus on the algorithms, completely abstract myself from data and continuous, so that I don't run into any of these controversies. But
I think I have an idea about how you could approach that, and I'll talk to you about it after. So.
But if you use basically the lazy version, you don't need to pass an input iterator. So it's as if you add a function that's return a new string.
So I am one of those users that Beeman was talking about. I want to take UTF-8 string and get graphemes from it, and that's all I want. And if that function right there had a convenience function on top of it that basically called that implementation, but the interface to it was I take a const char star, and the name of it is something like convert to UTF-8. It takes a const char star and I give it a UCS32 string, right, of my own devising. That I just passed. If I just passed those two parameters, that would be exactly what I needed. I think that kind of thing on top of this layer, I mean, this is great work.
Yeah, but a string literal is already arranged, so it will work.
Say that again?
A string literal is already arranged, I think, so it should work.
A string, what is already arranged?
Iterator.
String literal.
A string iterator by itself is a range?
String literal?
No,
Literal.
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 Oh, a string literal.
I think that may have been changed.
But the problem is that you may have the null character at the end.
Yeah, I hope that it was changed because because the problem with that is you can't distinguish a string
Yeah.
literal from a character pointer. I guess if you get it as an array, then
Right,
you're
you have
okay.
to
Yeah.
get it by
That
reference.
might just be a reason.
If you get it as an array, you're okay. Is that what they do? I assume. All right.
But so I've got basically I've got convert function, adapters convert, and segment function, and I also define for each segmenter, I've got a U8 segment, U8 convert. So I've got a lot of boilerplate functions that maybe try to make it easier to use, but I don't know if it's really useful.
This may be naive. What does it take to tie this to, say, boost regex? Is that
I don't really remember how boost regex works. I think we work on a string type. No, that's the one now.
I think you can choose the character type, and so you could work on.
Because I
Both
think
points, I suppose.
expressive works with iterators, while regex
Yeah.
works with strings or by basic car of T. So it might be easier to use with expressive.
Can we go back to the slide you had a moment ago?
This one.
Yeah. So, two questions. First of all, if I wanted to convert to QCS 16 rather than 32, can I do that? There's-
Yeah, you would use the UTF transcoder, and you pipe the UTF transcoder, and you want to, what do you want?
To 16-bit instead of
Let's say you would
32-bit?
write a car 16 or WCAR-T or whatever you want.
And then my second question was, in the lazy valuation version, I don't quite follow that. By the way, when you say string, did you mean UTF-8 data?
Yeah, yeah.
Yeah. I don't quite follow what's going on there. What is that returning to me? That's returning a
It's
container?
usually a range adapter, which
Ah.
will adapt the UTF-8 data range
So as
into
it,
a decoded range
as it,
as it iterates.
yeah, okay,
Quite lazy.
yeah, yeah,
But if you had to write the type, this expression will be quite complicated.
yeah.
Okay, so. Go ahead.
Any question?
I think that I think I have an I mean I've thought about Unicode problems both from a boost standpoint, from a standpoint of the standard library, and I've also written Unicode stuff that's used commercially. But I don't really know very much about Unicode. I don't have the kind of in-depth
You
knowledge.
say don't need to go very deep.
Yeah.
Because as I said before, whenever you go, when you try going into combining character sequences, that's why it gets complicated, because this means you can have different representation for the same combining character sequence.
I mean, I did enough work with Unicode to have a vast respect for the Unicode
But
standards.
this is not always needed, because for most languages,
Right.
you already have pre-composed forms, so you just
Right.
need to normalize it to NFC composed
Right.
form, and you can just deal with it.
But I think that there are, it seemed to me that there is a level of user, but what they want is a UTF-8 underscore string,
Mm.
which is it's pretty much like what you were
Yeah.
using standard string for, except that it knows.
Yeah,
that.
I think a string type could be practical, that does everything for you, that it always keeps the string in normalized form and everything.
Right, and you make a certain. But my problem was thinking about it that way, and is that then you do it, and it's not too difficult to do. To design, but you realize very quickly that's great for a lot of situations, but blah blah, it doesn't cover, and then all of the different types of range conversion and things like that. People are going to want that also, a user who's in a little bit deeper. And I'm thinking that you could build that UTF-8, UTF-16, and those are the practical. I mean, you probably need UTF-32, but
But yeah, the Institute is a no hope, so I didn't.
yeah. So, and then there's and those each one of those types has to be able to take any of the other common UTF types and probably others types, possibly with you providing some more, type traits or.
Yeah, but the UTF decode
Yeah.
already said.
So you've got that. You've got all those mechanisms there, and I think that.
Yeah,
Yeah,
it mostly I've got the algorithms. Maybe I don't have the right design to make it usable.
Yeah, I'm seeing nothing. I mean, just in this short overview, I have to use it, but it looked like a very nice design for the level that you're attacking at. But I'm just thinking to get a lot of user interest, you're going because I mean, a lot of people, the way they start using stuff is they use it at the really sort of high level, not too smart, and then they start realizing, they learn about it, and they say, oh yeah, I need this, and then they want to learn more and more and more. And if you've built a multi-level package, they can do that. I think there's actually a higher level where somebody wants what I thought of as a UTF string, that the internal encoding is unspecified, and that can be maybe there's a observer and a modifier function that can change the internal coding, but by default it just uses whatever it was constructed from, and that's a slower, dumber yet way of attacking the problem, but it's yet easier to use.
Then you got all the problems with you have to be compatible with STD string, Qt string.
Yes, yeah. I mean, you've got to eat. So what it comes down to is that you may have a non-templated, the actual string type, UTF string, may be non-templated, but every function, or many functions in it, are templated by what kind of a string type is the thing you're assigning, or the thing you're comparing, and likewise the output functions are templated, and you say you want a string out, and you're going to have to specify what kind of a string it is. And
Or it uses type erasure, and then you don't need to have
well,
templates on all the input functions.
Sure.
Any range.
Sure, but what I'm wondering is that, or just my impression is that you do need those multiple levels, the dumb but easy level, and not dumb isn't the right word, the solves a number of the more basic use cases. And then a level, maybe a second level that gets a little deeper, and then we come down to the power that's under the hood to be able to address a vast range of Unicode problems.
Yes.
While I agree that library is needed, I also don't think we know exactly what the interface for that library is yet. I would really like to accept something like this into Boost, so that people can go off and start writing their own little abstraction that they're using to solve those problems conveniently in their application based on this. And we will see, out of that should emerge what designs make sense.
Yeah.
You need to, before you start building a generic library, you need to look at use cases. And you need to look at concrete solutions to the problem. And we don't have enough of a view of concrete solutions to the Unicode string problem. To do that design,
I don't think there's much of a unique problem. It's mostly you have text, and you have to decide what you want to do with it.
Yeah, Dave,
You can say graph theory is like that. You have graphs, and you have to decide what you want to do with them.
There are some real graph problems, because maps do real problems, but for text, I don't know.
It's not a question of algorithmic problems. It's a question of design problem. What kind of an interface is going to make people's lives easy, and at the same time not introduce the kind of inflexibility or conceptual brokenness or whatever else that comes along when you try to take that design and apply it more widely. Those kinds of things, you can find out those things by looking at examples of what people actually do to solve their specific needs.
Yes?
I want to agree with Dave that as far as Boost is concerned, I think it's fine to bring this level library in and not, I would certainly wouldn't want it to be held up waiting for higher level abstractions on top of it. But what I'm still trying to grasp is, I know it covers very low level, or it appears to, and a little bit up, somewhat up from there, and I'm not quite sure how far up from there, and I'm curious about that, but it doesn't, whatever the answer is, it doesn't change my view of whether or not it should be accepted in the Boost.
But the thing I'm mostly concerned about is the whole converted design, which is the library is based on all what is it? Basically, the library is based on basically this concept that says, oh, you perform conversion. I don't know if this is good enough. I've used it for things other than Unicode. It can be used for base64 encoding or decoding. So you can do base64 encoding and decoding on the fly as with your data. You can also do it as a current conversion phase to do it for SDF stream. But I don't know if this is quite good enough. I'd really like to have some feedback on this. Maybe people know about the iterators. Because basically what I do to evaluate step by step is that I make a buffer which is aligned with the alignment of size of type, output type, of size max output. And the iterator adapter just calls step once, and as you iterate it consumes the thing from buffer, and then when the buffer is empty it calls again the converter to get the next step. And so you can go right, left to right, or right to left to the string. But it could have been better to do it maybe with a coroutine. So you would have the algorithm, the full algorithm that should yield each value. And this way, using coroutine, you can convert a generator into an iterator.
Right.
But I don't know if this is really a good idea.
Well, so this brings up another thing that I was going to mention. I think I might have mentioned this on the list, which is these are fundamentally segmented hierarchical data structures you're dealing with. And there's been a bunch of research into how to deal with that. I wouldn't say a whole lot, but there's a paper that Matt Ostrom wrote. Have you read that?
Yeah, segmented iterator. But I don't see
Segmented
the
iterators and
segmented iterator.
hierarchical algorithms, that one?
Mm-hmm.
So that, clearly that was written in a world where coroutines don't exist, right? You can do the same kind of thing much sort of more expressively with a coroutine, more easily. You don't have to disentangle quite so much stuff. But coroutines also require non-standard language exceptions, right?
The problem with coroutines, they need to handle the memory the coroutine is going to use, just when you create the context and everything.
There's allocation, but also you need non-standard facilities
Yeah,
to
you
sort of stack
need
and
to.
stuff.
Yeah. Well, you can do it with I think set jump and long jump. So that's mostly standard.
Well, set jump and long.
That's undefined behavior if you long jump over something
different
with a destructor. So
yeah.
so you can't do that in
But we do have a boost coroutine library.
Yeah, so I mean, if we can make it work, that's really cool. And then we have to start asking ourselves whether the interface to this sort of thing ought to be constrained by, the limits of what you can do in standard C++ or not. I'm not sure what the answer to that is yet. How portable is the coroutine library?
Sorry?
How portable is the coroutine library?
I'm not sure. I think the only implementation is in assembly for x86 and not very portable.
Is Is that just an implementation technique, or does it affect the interface, the public interface?
Well, this is when you want to extend the system, when you want to define a new converter, you define it in systems and
You,
model
you
is
have
custom.
to, okay, you don't just define a function and it's up to the system.
So
to
when
turn
you
it
want
out.
to define the UTF-8 decoder, you define a converter like this, which as input takes the car, as output gives the car 32, max output is 1, and so you beat up to 4 characters.
Mhm.
Generate 1. But we could do it simply, yeah, as a...
Yeah, I mean, you can implement that multiple,
Because there are already iterator adapters which are in Boost. They're in the details, I think, of Boost regex actually. And my iterations are very, very similar to the one in Boost regex. Basically the same thing. Except I've taken out all the decoding logic out of the iterator adapter and I've put it into a concept. And I can reconstruct an iterator adapter from any model of this concept.
Well, so I think Beeman's question about whether it's an implementation detail or not sort of hits at part of the heart of it. If we don't have reasonable assurance of portability of, that there can be a portable coroutine library on every platform, then you at least have to, seems to me, provide the other interface, the interface that doesn't depend on that. Now, whether you also provide an interface that you can take advantage of when you have coroutines, that might be really cool.
Well, yeah, you can evaluate this with the coroutine. It's just eco evaluation with a different output iterator to evaluate it with the coroutine.
Okay, so are you saying that the use of the coroutine is an implementation detail?
It's possible with this concept. You can evaluate this concept using a coroutine for lazy iterator.
So then, what are you unsure about? It sounds like you've got a great design, and you can, when you have coroutines available, you can use them.
Because the iterator adapter that deploys this converter is not very pretty. It does a lot of tests, and
It's expensive to flatten out the.
the lazy evaluation is quite more expensive. Than
Right. So this is where you might also consider doing the hierarchical algorithm approach, because that's what that's how you save doing a lot of extra tests. It's the same. It's the classic iterating over a deck problem. If you've got this flattened view of this hierarchical data structure, at every step you have to check whether you're at the end of the segment, and you also have to check whether you need to hop into the next segment or something like that. It makes it very expensive.
Yeah, it's a very common problem. But the problem is that it's never been integrated into anything. I don't think the Boost range supports any kind of segmented iterators.
Yeah, but it's a pure extension of the existing iterator.
Yeah, because you have to provide both the legacy as well, the legacy iterator, right? You have to you provide two kinds of
No.
iterator.
No, you provide one kind of iterator that can either act as a legacy iterator or can expose its segments, and you have to write algorithms that know how to cope with that if you want to take advantage of the extra speed. But if you write algorithms that think all of your sequences are flat, they'll still work. So the nice thing about that is that you could start providing segmented algorithms and segmented iterators, and those two things would work together quickly, and it's kind of a smooth degradation of performance.
But yeah, both you use whichever you can.
Sorry?
So you would have both, so you use whichever you can, because I know a lot of code deals with iterators, and simply very hard to port it to use segmented iterators.
Yes, and they would just use the flat iterator interface and get as best performance as they could, but then they can be optimized.
Yes.
Have you looked at class path in Boost File System version 3, specifically the conversion stuff that goes on there between UTF-8 and
No, I
UTF-6?
haven't.
It's the abstraction there is that a path is just a path, and that is going to be on Windows. It is going to be it's platform dependent what it is.
Yeah, so you use white characters on Windows?
Internally, yeah, on it's wide characters on Windows, it's char on, so it's not a templated class anymore, it's just a single type. So and then there are, you know, all the constructors and everything like that are templated. And we'll convert, and then it has to have its own converters, and it's terrible in the sense that
So what do you convert on POSIX systems? Do you convert to UTF-8 or do you convert to the local?
well, it depends on the, if the input is a string, it's just passed through
Yeah.
unmodified, because that's the POSIX spec for that sort of thing, and any other behavior would be very unspecified. If the input is UTF-16, for example, or anything except just plain char, then it goes through a code convert facet, and I ran into the exact same stuff you were talking about. Code convert's just awful, but it is the standard way of doing conversions, and I didn't feel I could tackle any more than, I didn't want to bite off more than I absolutely needed to. So I said, you've got to, you provide this little conversion thing that is just a caller to, it's a code convert facet, basically. But I'd love to take some, and that would have been so much better if there was some string types, UTF-8, UTF-16 sort of string types, and I didn't have to provide the mechanisms. That there was
but
a standard.
you have to make a decision of what the string type is going to be. People might not be happy with that.
Well, I know, no, the implementation, the string type internally
for
is
file system stuff, you just use something that matches the system.
Yes, it just matches the system. And that's the internal string type. The external types are whatever the user wants. It's got to meet certain characteristics, and it's usually going to be char or wide char, or as we get into OX, char 16 or char 32. But there's no reason in principle, and I don't think in practice either, why it couldn't be, just a completely different string type. In the path class itself is having to provide a great deal of machinery, probably not doing as good a job as a library like this, that I could have, at the least, I could have used it to construct all my conversion machinery and not had to roll my own, and that would have been better. It'd be very interesting to try to apply it to that.
Dave?
So the strings that are out there in the world, the string classes, so you say you don't want to have to choose for people what string class they should use. It's very reasonable. Just lots of code out there using existing string classes. Those classes, are those typically, is the encoding encoded into the type, or typically are they like std string where you could put any encoding in there, as long as it encodes into 8-bit?
I think there is both.
Okay, so you've got both kinds.
Yeah.
So I mean, for the ones where the encoding is tied, it's reasonably easy to build the equivalent, the coordinates concept maps or whatever, such that you're able to generically deal with them and know what encoding they are. The other ones, clearly not, right? Clearly, when somebody gives you one of those, they have to tell you what it means. So I think you can easily solve part of the problem. The other part, I'm not quite as sure about. I mean, if you could imagine templatizing the entire library on some policies that say, this type is encoded as UTF-8, and this type is encoded as UTF-16, then you could,
It would just be the tag range, basically.
Huh?
It would just be tagging the ranges with encoding. No?
Well, I'm back up at the level of of people who want to deal with strings as opposed to ranges. But that's the level at which I was thinking. But yeah, I guess you can use a tag range, sure. The question is, at what level do you ask people? So, for example, if I'm writing a program and I'm using a string type that doesn't encode its encoding in the type, but I may have a protocol basically where it's always UTF-8, right? I mean, that's what I do. So it would be good to get a hold of a converter object that encoded the knowledge that this type is always UTF-8, and then I could reuse this thing over and over again. You know, some easy way to get that, and not have to rename the whole thing, and you know, not
So
have to
just
specify the whole mapping of that type into its encoding. You know, so maybe I can declare an object, right? That maybe it's an empty object, so static initialization takes care of everything, and you know, I brace initialize it, and now I have a converter for this kind of set of relationships between types and encodings.
That, yeah, baked in. Yeah, no, that's, so what we're saying is that first there's this level where nothing's baked in. One level up are things like converters, where you bake in knowledge of one of the types. You know, or you bake in the knowledge of a type. Then the next level above that are stringy things, where you bake in the knowledge. And that each of those levels have important users and use cases.
I think that's probably right. I mean, you know, once you start converting things into an object of a different type because of the way C++ is, and especially in O3, you're going to pay for a copy.
Mm-hmm.
And you have to be prepared for that if you're starting to deal with these stringy things. But that sort of gives you a spectrum of levels at which you can deal with the library without dictating too much, I think. If you want to look at details after the class, I could, like, you know, write some stuff down with you, if you think it'll help.
Yeah, well, I did this library 2 years ago, and basically I don't really know what to do with it, because I don't know if it's good enough for what we need in Boost. I don't know if it's review worthy, basically.
Does it contain all of the sort of massive table information that is encoded into things like you know, the big Unicode library that's out there?
I generate a Unicode character database. I don't have all properties in it. I don't do all things related to collation, sorting, because I don't have.
Dave, the source of a lot of the tables is available from the Unicode consortium. So,
I know. I'm just asking.
okay.
I'm trying to. He's not sure whether the library is worthy for Boost, and I'm
Yeah.
trying to sort of figure out how extensive is it. What is it leaving out? So you're telling me now. So there are some things that it leaves out. And
Does it need more features, or does it need to be polished? Sometimes it's the same.
How about the and also what is the state of the documentation?
Is it useful? Do you use it?
Well, I only do high performance computing, so I don't really use much.
You only do what computing?
High performance computing?
I'm sorry. I didn't-
HPC.
High performance. Oh, HPC. Okay.
So I don't use much text.
Does anybody use it?
Uh,
Do you have users?
Not really, because I think it's not really practical to get it off the sandbox and set it up running, because you need to build everything, library. Generally, I think it's quite hard for libraries in the sandbox to be using.
Okay. All right. I see that.
But I don't have any user I'm aware of.
I'm trying to remember, isn't there in one of the detail sections of some of the libraries something very similar?
Yeah, with details of regex, there is a.
There are some similar parts.
You try to adapt to that do on the fly UTF-8, UTF-16 conversion. It's quite similar to what I have.
Question, the Unicode data, you refer to as a database, how is that physically incorporated into the library?
It's a shared object on DLL.
What?
It's a
Shared
DLL.
DLL, shared object DLL.
Oh, so anyone who uses this library has to have that.
Yeah, you
DLL.
need to link it.
What's that?
You need to link it, yeah.
Yeah.
I don't remember how big it is. I think it's maybe 500 kilobytes.
But it's static data, so there only needs to be one on the system.
You can link it statically, I assume, but,
Yeah, you could.
but,
I thought it was better to have a shared object because since 500 isn't that big actually, but I thought it would be bigger, so I didn't want to duplicate it too much.
I think, you know, if what you're looking for is it ready for Boost, I think the main criterion is going to be, does somebody want it? Does somebody want this interface? And so far,
And I don't think there's anyone because very often when I ask for feedback, I don't get any feedback. So I don't really know what's wrong with it. So maybe someone can tell me. Yes.
Just sitting here looking, thinking about the use cases we have, we have kind of a home-baked solution that uses Uniscribe and some other stuff, and that range-based iteration would be really simple to go to the beginning or end of a grapheme, for example. So, I mean, I can see concrete use cases. I guess I just have to pull it out and compile it and see if it works.
Yeah.
Yeah, I for one want this library as is. I think it would be nice if there were some convenient functions on top, but I would use the shit out of this if you put it in Boost. Yeah, I think this is exactly the kind of thing that the list needs more submissions of this variety.
you have a volunteer for a review manager?
It's not good at hand.
Oh yeah, and about the database, you only need it if you actually use features that are required. You don't need to use database if you're just doing UTF transcoding. You need it for everything based on graphemes, normalization.
Would that
That's
same
nice.
would that same information be available, like the code pages that Windows provides, for example?
Yeah, you would have to write, and I've been trying to make an ABI as simple and as simple as possible, so that you could easily replace the library by another implementation. So you could be able to write a new implementation that takes the values from Windows.
What, to what extent has it been tested
A bit, but not greatly.
with multiple compilers?
Yes.
And do the test cases provide pretty good coverage of the library, or do you think that, what do you think?
I think they're quite insufficient at the moment. I think they're quite insufficient, the test unit case. The more examples than unit tests, really.
Okay.
They test all features, but don't test with all possible data you could have. Yeah.
So here's a nuts and bolts question. If you say nobody's using it, how good is the test coverage over the library? Does it have good unit test coverage? Or?
No, that's what he's saying, they're basically example level coverage.
Oh, okay,
not-
so there is no real unit test coverage.
So Boost today has dependency on ICU. Is it possible to replace that dependency with this?
It would be possible. It doesn't do as many things as ICU, but you could use that instead of ICU.
Because we don't use all of ICU and Boost. Is
Well, that might be a good place to start, is to do that replacement, make sure that everything is covered.
Oh, yeah, it's whenever.
I would like that confirmed or denied, though. Are you saying we can replace our use of ICU?
But I don't really know what ICU is used for.
So
It's
we
used
can't
in Reg
necessarily-
X, I know.
So we can't necessarily replace ICU and Boost with this because we don't know if we're using features from ICU that you're not supplying. Is that right?
Yeah, but I don't know what regex uses ICU for.
Exactly.
Yeah.
Well,
So we
we
don't
can
we
ask.
don't know that we can replace
But,
ICU with this.
Right.
Is that true or not? I just want to.
yeah, I don't
Okay.
know. I will have to
Okay, we don't know.
turn that.
All right.
But the correct database provides all properties, so this probably covers all the needs you might need for regex. But
Okay, we're not sure, but probably.
possibly.
Okay. Possibly.
Yeah, and I looked at this for Spirit as well, because I wanted Spirit to use my library if possible, because there was some Unicode support going on. But unfortunately, I think George Guzman didn't really like having a big binary as a library for the database. He liked having everything into a new file. So
Right.
he said he'd rather not use it. But I don't really agree with that.
Well, I don't want to have to pull in a binary when I have a header-only parser. That'd be why.
But then again, do you expect to be able to deal with all kinds of Unicode with a header only?
No, but for my use, I don't have to do Unicode. I can do network I/O
Right, so
with
it would,
Spirit now.
so, you know, clearly Spirit could use this when you need Unicode, but you wouldn't want to impose it on every user of Spirit.
So you'll be able to match certain types of characters, check that you are on graphing boundaries.
Do what?
Could be used to check that characters have certain properties, more than unknown alpha, things more advanced, and that characters also lie in the right boundaries when you match them. There could be interesting uses, but it's mostly extra stuff. Okay. Well, thank you. At least I got some feedback. First time meeting.
Certainly an interesting presentation at the very least, and the library seems very interesting.
I'm not very good at making presentation, nor speaking English, but if you manage to understand, it's good enough.
Yes.